Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here. This is video 22 on our GCSE Higher revision series. We're talking about standard form today. As always, a reminder, this video is not supposed to teach you from first principles the understanding of standard form and why it works. It's a quick summary of the key facts you need to know for the exam and then a practice of some exam questions. As always, I'm going to start off by doing some examples just to show you the basic ideas. Take notes down for that, fully concentrate, maybe even make a revision card. After that, there will be several exam questions. Pause the video when I show it to you, try it, then play and mark it off mine. 100% check you've got it right. If you're doing the course online, then if it's all right, green tick that video. If it's a bit wrong, couple of mistakes, amber, you might need to revisit those topics, and if it's red, you probably need to watch the video again and start over or ask your teacher for help. Okay, firstly, standard form. Very basically, what is it? Well, standard form is a way of writing big and small numbers. It's a way of writing big or small numbers. And it's a way of writing them quickly and efficiently. So quickly and efficiently. So it always comes up in questions to do with big or small numbers. What does a number in standard form look like? Well, it always looks like this. It's some number multiplied by a power of 10. 10 to some power. I'm going to put 10 to the power of n. Now, this number, must this number be? It must be between 1 and 10. It can't be 0.5 because that's below 1. It couldn't be 12 because that's above 10. It's got to be some number between 1 and 10. And what about this? This is always a whole number. Now, if it's a positive whole number, it talks about big numbers. And if it's negative whole number, if that was a negative number, it would be about small numbers. So that's what a number in standard form always looks like. Some number between 1 and 10 multiplied by a power of 10. If that power of 10, if the power is positive, we're talking about big numbers. If it's negative, we're talking about small numbers. Right, let's introduce you to some ideas here. Firstly, let's write a big number like this in standard form. What we do is follows. The first non-zero digit is the key. That's 6 there. So our number between 1 and 10, we're going to take that to be equal to 6. So it's 6. Now what power of 10 is it? Well, you count how many digits after that first non-zero. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we're going to say that 6 multiplied by 10 to the power of positive 9. Simple as that. What about in this case here? Well, again, we highlight our first non-zero term, which is a 6. We put a line after it. There are 9 terms after this. So our number between 1 and 10 is going to be 6.3. We need to capture the fact that it's not 6, it's 6.3, and we're going to multiply it by 10 to the power of 9. Now, some students say, why isn't it 63 times 10 to the power of 8? The reason is this number has to be between 1 and 10. So we write our 6 down, then we write 0.3, and we stop where the zeros start. Then we count how many digits after the first 6. Right, what about the next one? Well, the key digit is the 5 as always. Okay. Now what we have to do is we have to write a number between 1 and 10 that summarizes this. We're going to write 5.02. We write 5, after we've written our 5, we write a point, and we write up to where the non-zero digits stop. Now, how many non-zero digits after the 5? 1, 2, 3, 4, 5, 6. So it's going to be 5.02 to the power of 6. Now let's go backwards. We're given standard form. Let's convert it into an ordinary number. So this was ordinary going to standard form. Let's go standard form to ordinary. So 6 is our first digit, and this 7 tells us we've got 7 digits after the 6, and they're all zeros. 1, 2, 3, 4, 5, 6, 7. Only put your commas in at the end, every 3 from the end. So 3 there and 3 there. What about this one? Well, we write the 603. And 6 is where everything depends on. The 7 tells us there are 7 digits after the 6. So including these, that would be the first, the second, and now we're going to go third, the fourth, the fifth, the sixth, the seventh. Comma, comma there. That's how that number would look. What about this one? Well, we write down the 5 and the 1. Now this power of 5 here tells us there are 5 digits after the 5. So including that 1, there's 1 there, 2, 3, 4, 5. Put your commas in. Right, let's do small numbers. Well, here the non-zero digit is a 6. And how many digits before the 6 this time for small numbers? 1, 2, 3, 4, 5, 6, 7 multiplied by 10 to the power, not of 7, but negative 7 because it's small. What about this one? Well, again, the first non-zero term is 6, so that's going to be vital, but we write 6.3 to capture the fact that it's not just 6 on its own. And we count how many digits before the 6. 1, 2, 3, 4, 5, 6, 7 multiplied by 10 to the power of not 7, but negative 7. What about this one? Well, the 3 is the key number, so we write down the 3, 0.05. We go up to where we have non-zero digits, multiplied by 10 to the power of 1, 2, 3, negative 3. What about this? We're going from standard form to ordinary. This tells us we've got a 6, and this negative 7 tells us we've got 7 zeros in front. So 0, then you put your point, so that counts as 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros, 6 zeros, 7 zeros, then put your 6. What about this? Again, 7 zeros here, so we're going to put 0 point, that was 1 0, 2 zeros, 3 zeros, 4 zeros, 5 zeros, 6 zeros, 7 zeros, and then we write our 6, 0, 3. This last one here, 5 zeros, 0 point, that was 1 0, 2, 3, 4, 5, and we write our 5, 1 there. So that's how to convert big and small numbers to and from standard form. The next thing we have to do is to be able to calculate with standard form without a calculator. So we're doing 4 times 10 to the 6, a standard form number, multiplied by 2 times 10 to the 3. There's a nice way of doing this. You just deal with the numbers separately. You do 4 multiplied by 2, and you do 10 to the power of 6 multiplied by 10 to the power of 3, using our rules of indices, which was video 21. So 4 multiplied by 2, well, that's 8. 10 to the 6 multiplied by 10 to the 3 is 10 to the 6 plus 3, which is 10 to the 9. That number's between 1 and 10, we're fine. Same thing this one here. 3 multiplied by the 2 and 10 to the 6 multiplied by 10 to the negative 2. So 3 multiplied by 2 is 6. 10 to the 6 multiplied by 10 to the negative 2. Well, 6 add negative 2 is like 6 take away 2, which is 4. So multiplied by 10 to the 4. And that number's in standard form. Okay, what about this? First line, we do 4 multiplied by 3. So we do 4 multiplied by 3 for the number bit, and 10 to the 6 multiplied by 10 to the 3. Now, this is where there's a slight trick. 4 multiplied by 3 is 12, and 10 to the 6 multiplied by 10 to the 3 would be 10 to the power of 9. Now, there's a problem. This number's not in standard form. That number is not between 1 and 10. So we have to force it between 1 and 10 by dividing by 10 here. So in order not to make the answer any different, we increase the power of 10 here. And that is in standard form. These will always be 2 marks. 1 mark for that working, 1 mark for that answer. A way I remember it, a little trick, is that if you've just done a multiply and you're bigger than 10, what you do is the 12 you'd write as 1.2 and you'd increase the power because you're doing a multiply. Let's have a go at this, same idea. So 5 multiplied by 7 is 35. 10 to the 6 multiplied by 10 to the 3 would be 10 to the 9. You're not allowed to have 35, so you write 3.5. You've just done a multiply, so you increase the power by 1, like that. Okay, division works a very similar way. You just have to divide the numbers and subtract the powers. So we're going to do 4 divided by 2 and 10 to the 6 divided by 10 to the 3. So 4 divided by 2 is equal to 2. 10 to the 6 divided by 10 to the 3 is 10 to the 6. Take away 3, which is 10 to the 3. Right, same thing here. we're going to do 4.8 divided by 1.2 and 10 to the 6 divided by 10 to the 3. Now, 4.8 divided by 1.2, how many 1.2s go into 4.8? Well, 4 of them. So this answer would be 4 multiplied by 10, 6 take away 3, 3. Now, here's where the similar trick comes into this here. Let's have a look at these ones. 1 divided by 2 is 0.5. Be careful. Read it as you see it. 1 divided by 2, not 2 divided by 1. So 0.5 multiplied by 10 to the 3. Now, you're not allowed to have this number lower than 1. So, in a way, fudge it so that it's bigger than 1, between 1 and 10. Multiplied by 10 to the power of 2 it's going to be. You've just done the divide. This time you're going to reduce the power. The reason you're doing it, you're actually multiplying this by 10. So as not to change the answer, you divide this by 10, i.e. reduce the power of 10. 1 divided by 4 is 0.25, multiplied by 10 to the 7 divided by 10 to the 5, which would be 10 to the 2. That has to be between 1 and 10, so you fudge it to be 2.5, multiplied by 10 to the power. You've just done the divide. This time you reduce the power by 1. Okay, we're nearly at the end then. One last thing we've got to be able to do is do calculations on our calculator with standard form. So let's have a look at this. It's a typical type of question. Right, so we are given that y squared is a multiplied by b divided by a plus b. And what we're told is we're told what a is in standard form, we're told what b is, and we're asked to find y. Not y squared, remember, y. Then it says give your answer to 2 significant figures. So this is supposed to be a calculator question. So what we do is we get our calculator up here. I want to show you how to do standard form in a calculator. Say we want to type that number in our calculator, we would write 4.3. There's a standard form button here, times 10 to the power of x. You just press that button like that, and then you would write the 6. That makes the number in standard form. So let's work out y squared. Press the fraction button. A times b. So let's put brackets around a. 4.3 times 10 to the 6, close brackets. And we're multiplying it by b, which is, open brackets, 6.03 times, times 10 to the power of negative 3. Close that bracket. Go down. And then what we want to do is a plus b. So open up the brackets again. A is 4.3 times 10 to the 6. And then we're plussing, open brackets, 6.003 times 10 to the negative 3. Close brackets. Now that's exactly as it should be in our calculator. On top they're multiplying, on bottom they're adding. Now I've just spotted a little mistake, that should have been a 3. Okay? And now all we have to do is press equals. Now our calculator gives us this here. So our calculator says that y squared is equal to, and we're going to write this all down, 6.02. So 6.02. 9999992 9999 1 2 3 4 5 6 times 1 2 3 times 10 to the power of negative 3, it says. Now that's y squared. So to get y, we need to square root that answer. Because that's y squared, we need to square root that answer. So square root answer, and we get the following. That y would be equal to 0.077653. 77653. Now they said give your answer to 2SF. Not significant, not significant. First, second. So that's the second significant. You'd round that to 78. So y would be 0.078. But it says give your answer in standard form. So y would be equal to 7.8 multiplied by 10. It's a small number. You count how many digits before the 7. 1, 2 to the negative 2. And we're done. Okay, so that's revision on standard form, how to convert between them, how to multiply and divide with them, and how to do them on the calculator. Let's do some exam questions. I'll show you a question, pause the video, do it, I'll go through the answer in 10 seconds, you mark your work. Start with the first one, here we go. Okay, so we're going to write this number in standard form. We're going to write down 3.7 to represent that number, and we count how many digits before this 3. 1, 2, 3, 4. So it's multiplied by 10 to the negative 4. What about this one? 8.25. That should have said to the power of 3. There was a little mistake there. So we write down our 8, 2, and 5. That 3 tells us there's 3 digits after the 8. 1, 2, and the third one, where we must put 0 in its place. What about this? Work out the following. Now this should be without a calculator. So what we do is we're going to multiply the numbers. 2.1 multiplied by 6. 2.1 multiplied by 6. If you're not sure, just do 21 multiplied by 6. 6 times 1 is 6. 6 times 2 is 12. 126. And so 2.1 multiplied by 6 must be 12.6, 10 times smaller. So that multiplied by that is going to be 12.6 times 10 to the power. We're multiplying, so we're adding these. 8 add negative 5. You've got 8 and you combine it with negative 5, you get positive 3. Now, this is a 2-mark question. The problem with this is it's not between 1 and 10, so you make it 1.26 multiplied by 10. You've just done the times, increase the power by 1. So the answer is 1.26 multiplied by 10 to the 4. Pause the video, have a go. I'll go through in 10 seconds. Okay, so write as an ordinary number. We're going to write down the 6, the 4 and the 3. That 5 tells us there are 5 digits after the 6. 1, 2, and we must fill in zeros now. So 1, 2, 3, 4 and 5. Put your commas in after. Work out the value of this without a calculator. Well, we're doing 8 multiplied by 2 multiplied by 8 is 16. 10 to the 7 multiplied by 10 to the negative 12. That's going to be 10 to the 7 add negative 12. 7 add negative 12, which is like 7 subtract 12, which is actually negative 5. So like that. Now, we have to write this as 1.6 times 10 to the something because this number has to be between 1 and 10. And what we've done here is we've divided by 10, so we're going to increase this power by 10, 10 to the negative 4. Increasing that by 1 will bring it to negative 4. 1.6 times 10 to the negative 4. Okay, next one. Pause the video, have a go. Okay, 10 to the power of 0. Anything to the power of 0 is 1. Write this as an ordinary number. Well, this negative 5 tells us there are 5 zeros. 1, put a point after it. 2, 3, 4, 5, and 6, 7, like that. Work this out. Well, 3 multiplied by 9 is 27. 10 to the 7 multiplied by 10 to the 6 is 10 to the 13. That has to be between 1 and 10. Make it 2.7 times 10. You've just divided by 10. You now need to increase this by 10, like that. 2.7 multiplied by 10 to the 14. Next one. Pause, have a go. I'll go through in 10 seconds. Okay, so I write this as an ordinary number. We write down our 8 and our 2, and this 5 tells us there are 5 digits after the 8. 2 is one of them, so that's 1, 2, 3, 4, 5, comma there, comma there. Write this in standard form. The 3's are most important, so we write down 3 and then 76. And how many digits before the 3? There are 1, 2, 3, 4. So it's times 10, not to the 4, but to the negative 4. And work out the value of this without a calculator. Well, 2.3 divided by 4.6. 2.3 divided by 4.6 is a half, is 0.5. How could you know that? Well, 23 divided by 46 is similar to this, and you can work out that that's a half because you could divide the top by 23, it's 1. You could divide the bottom by 23, it would be 2, so you get a half. So this answer here would be 0.5 times 10. We're doing a division, so we take them away. 12 take away 3 is 9. There's a problem. That's not between 1 and 10, so we make it a 5. You've just done a divide, let's decrease this power. Or you've increased that by 10, not so as not to change the answer, you decrease that by a power of 10. Okay, another one, pause the video, have a go. Right, going through, the 7's the key number, so we write down 7 and then 0.9. There are 1, 2, 3 digits after it, so times 10 to the power of 3. What about this one? 3 is the key number, so we write 3 and then 0.5. We count how many digits before the 3. 1, 2, 3, 4. So it's multiplied by 10, not to the 4, but negative 4 because it's a small number. Now this one, I'd write it as a division. I'd write that as 4 multiplied by 10 to the 3 divided by 8 multiplied by 10 to the negative 5. Now 4 divided by 8, don't say that's 2, it's the smaller divided by 8. 4 divided by 8 is a half, so 0.5 times 10. 3 take away negative 5, because we're dividing 3 take away negative 5 would be 3 plus 5, which would be 8. So we'd have that. This has to be between 1 and 10, so we make it a 5 by increasing by 10. So as not to change it, we need to decrease this by 10. That would be our answer. 5 multiplied by 10 to the power of 7. And last question of the day, you're supposed to use a calculator for this. So pause the video, try and work out p squared, given that x and y are this, and then work out p and give your answer to 2SF and in standard form. Okay, so p squared, we're going to get the calculator out, and what we're going to do is we're going to press the fraction button. X take away y, so x is 8.5 times 10 to the 9. I should have written a brackets around it for safety. So that x is there. Then we are subtracting, open brackets, y, 4 times 10 to the 8, close brackets, over x times y, so open brackets, 8.5 times 10 to the 9, close brackets, times 4 times 10 to the 8, close brackets, and press equals. Our calculator gives us that for p squared, so 2.382, so let's just write 2.382 ... times 10 to the negative 9. But we wanted p, not p squared, so we're going to have to square root that. So press square root your answer, and you get that. 4.8809, so 4.8809, 35301, 35301 times 10 to the negative 5. Now, we're nearly there. We've got P, we've got 3 out of the 4 marks, we've just got to round to 2SF now. That's the first significant, that's the second. That 8 would make that a 9, so P would be 4.9. Everything else would be 0, so we wouldn't write, multiplied by 10 to the negative 5. And we're done. I hope you found that very quick video on standard form and all the ways it can come up in the exam useful. Thanks loads for watching.